Hi everyone, in this video we are going to introduce a new kind of function which is called radical functions, and of course the corresponding, if it's not a function then it's just an expression and it would still be called a radical expression. So let's first begin by trying to understand what the square root operation does and how it acts on numbers. Okay, so the idea behind square roots is to collect copies in pairs, okay, after factoring. What does that mean? That means, for example, to find the square root of 81, right, I'm going to factor 81 first. When I factor 81, it's not even, so it cannot be divided by 2. So I try the next prime number, which is 3, which gives me 27. Same process, it gives me 9. Same process gives me 3. And I stop when there is a 1. Okay, which means that 81 is 3 times 3 times 3 times 3. So square root of 81 becomes square root of 3 times 3 times 3 times 3, and you collect pairs. Okay, so this is going to become 3 times 3, which is 9. So whenever you have two copies of the same object inside the square root, you can bring that outside the square root. So let's do the same with square root of 4 over 49. Now the square root function, it can be distributed as square root of 4 over square root of 49. But what is 4? 4 is 2 times 2, and 49 is 7 times 7. Now there's a pair of 2 and there's a pair of 7, so this is 2 over 7. In some cases it may not be straightforward, like in this one, 0.0064, and in this case what we're going to do is we're going to write as a fraction. Okay, which means this is 1, 2, 3, 4 places of decimal. So this is 64 over 1, 2, 3, 4, which then becomes square root of 64 over square root of 10,000. Right, so if we actually break this down, 64 is 2 times 2 times 2 times 2 times 2 times 2. And 10,000 is 10 times 10 times 10 times 10. So there's 2 pairs here and there are 3 pairs here. So this comes out to 2 times 2 times 2 over 10 times 10, which is 8 over 100, which is 0.08. Okay, so that's how it works with numbers. You can kind of imagine that when we work with expressions now, since we know how to factor, the same rules are going to be followed. So if we have 2 copies of the same factor, then one of them will come out of the square root symbol, and if there is only one of them, it remains inside. For example, one typical question could be that you are given a radical function and you're asked to evaluate the function at 2. So this is the process in which we replace x by where we are evaluating, which is 2 in this case. So this is square root of 10 minus 6, which is square root of 4, which we know to be equal to 2. So f of 2 is 2. Similarly, let's say g of x is negative 64 minus 8x, and we are trying to find g of negative 3. So g of negative 3 is negative 64 minus 8 times negative 3, which is negative 64 plus 24, which is negative 88. Now here I want to factor 88. It's even, so 2, 44, even again 22, even again 11. That's a prime, so I can stop. this is negative square root of 2 times 2 times 2 times 11. There's one pair of 2, but the other numbers don't have pairs. So the one pair gets out, and I'm left with a square root of 22 inside. So here's an example of a case where not everything inside the square root forms a pair with another number or another copy of itself. So in that case, what you do is whatever forms a pair, you bring it out as a whole number, and whatever does not form a pair remains inside as it is. Now, one new, well, not really a new addition, but when we did functions, the two operations or the two things that were illegal, not allowed, were division by 0 and square root of negative numbers. Which means that if you have a radical function, we now are able to find the domain of such a function. So what we need is, we need the term inside the square root to be greater than or equal to 0. Which means that this comes down to becoming an inequality which we have learned how to solve. So I need 3x plus 12 greater than or equal to 0. Why can it be equal to 0? Well, that's because the square root of 0 is defined. Square root of 0 is just 0. So I follow the steps here. This is 3x is greater than negative 12. Divide by 3. That gives me x is greater than or equal to negative 4, or x is negative 4 to infinity, or I draw this negative 4 and it's all of these to the right. Okay. Now, one thing that we need to define in order for this to be a function is that whenever we take the square root of something that is squared itself, it's the absolute value. So we always take the positive value. So for example here, square root of negative 6 squared would be absolute value of negative 6, which is positive 6. Square root of x plus 5 whole squared would be absolute value of x plus 5. Square root of x squared minus 4x plus 4, this here is actually x squared minus 2 times x plus 2 squared, which we learned from perfect square factoring, that is actually x minus 2 whole squared, which comes out to be absolute value of x minus 2. Okay, so when we have expressions in terms of x and you have a square root of something that is squared, then you have to be careful. You have to be careful that you are using the absolute value when you are computing it. Okay, so we're going to stop here in our discussion for square roots, and then we will proceed with higher roots like cube roots, fourth roots, fifth roots, and see if there is any very obvious pattern that we can make use of. Okay, thank you.